All right, here is part 2 of the law of universal gravitation. In part 1, we learned about the equation. We learned about how big G is not the same as little g. You learned from the videos how big G was determined. The force of gravity that we're solving for is really the gravity that exists between two objects. Then we did an example. We found the gravitational force between the Earth and the Sun, and we found that number to be 3.5 times 10 to the 22nd. So it's a huge number. All right, here's example 2. We're going to work with some objects that are not huge. So let's say you're in gym class. A basketball and volleyball are 5 meters apart on the gym floor. What is the gravitational force between them? Right, remember, you can pause this at any time. So let's say the mass of the basketball is 0.5 kilograms, and the volleyball is 0.28 kilograms. Those are real numbers. I didn't make those up. Okay. First step is we need to identify the givens. So we have a couple of givens in here. We know that they're 5 meters apart, and we've got some masses. So take a moment, pause the video, and write your givens. All right. So we know that the mass of the basketball is 0.5. We know the mass of the volleyball is 0.28. These are both kilograms. We know the distance between them is 5 meters. So here's my basketball. And here is my volleyball, slightly smaller. All right. And they are 5 meters apart. So from center to center, that's 5 meters. Okay. So kind of like, the bigger object like the sun, the smaller object like the earth. So we also know our gravitational constant is 6.67 times 10 to the negative 11th. And this problem wants to know, what is the gravitational force that exists between them? So we want to know, what is this force? What's keeping them apart from each other? So we're going to use our equation, F sub g equals the gravitational constant times the one mass times the other mass, all over their distance apart squared. All right, take a moment and plug in your values. Remember that scientific notation needs to go in parentheses. What was that, 0.5? Okay, so I'm just plugging this in. Gravitational constant, mass of the basketball, mass of the volleyball, all over the distance squared. All right, at this point, pause the video. and calculate your value. If you've noticed, I do this usually in two parts, especially when I'm showing you guys. So I want you to be able to see if you're getting the correct numerator, like where's the errors coming from, essentially. All right, so pause it and plug it in. All right, when you do this, you get 6.67 times 10 to the negative 11th times 0.5 times 0.28. All right, so what you should have gotten from your numerator is 9.338 times 10 to the negative 12th all over distance squared. Okay, so divide your answer by 5 squared. And we should have gotten the gravitational force is 3.7 times 10 to the negative 13th Newton. All right. That is the correct answer. So take a look at what you got. If you didn't get this value up here, check your exponents, check parentheses. If you didn't get this value, right here, make sure that you have squared the denominator. All right. So why is this answer so tiny? All right. So this answer is, 0.0000. All right, you get the point. So it's really, really small. Compared to our first example that was to the 10 to the 22nd power. The discrepancy of the forces is that the sun and the earth are huge objects. So yeah, that force between them is going to be huge, thus the 10 to the 22nd. In the grand scheme of the universe, a basketball and volleyball are really tiny. So that's why this force is 10 to the negative 13th. It's really small. So when you're doing these problems, you need to take a look at your objects. All right, if they're everyday objects, the force between them is going to be small, probably to a negative exponent. If the objects that you're working with are large bodies in space, Venus, Saturn, Mars, Jupiter, Earth, the sun, the moon, satellites, the force is going to be really big because the objects are really big. So that's one of those aspects of, does your answer make sense? Thank you for paying attention. We're done.